Welcome! It's me, John Park, and this is John Park's Workshop. Here we are again. Can you believe it? So thank you for stopping by. If you want to chat, we've got a bunch of people over in the Discord. I don't have Discord displayed right now because I have some suspicions about Discord screwing with my audio settings sometimes. So I'm actually looking on a little iPad that I have mounted over here. So I will keep an eye on that chat. I can also see the YouTube chat. So if you want to come and hang out and talk, and I know there are people who are also on other services like Twitch and Periscope and Facebook. Hello everyone over there. I just won't be able to see your chat because I just don't have that kind of multitasking abilities. Well, to get started, let's see, what have we got today? We've got some continued explorations of E-Ink, this time with the Magtag, which is our new board. I'll be talking about that and showing some of the progress I've made hacking on it. And what else? I've got a really fun MakeCode Minute for today, something new and interesting to me at least, a new way to use one of our devices in MakeCode that I'm excited to show. A cool game of the week pick that I want to show you, someone who's getting started with a new game that looks very promising and interesting, and some cool techniques to check out there. And a few of our other sort of housekeeping-y details and things. I'll show a pick of the week video from this past week. What else? That may be it, but I think that's a lot. I think we'll have a fun time doing it. So let's get going. All right, so first of all, let's not forget that we have got a job board that you can go and check out if you are looking to find some work, or if you're looking to hire someone to do some work. Go head on over to jobs.adafruit.com. This is the site. If you head here, you'll see some positions where people are looking to fill anything from full-time to part-time to contract to freelance positions. That's just at jobs.adafruit.com. And if you click on available for hire, you'll see people advertising their skills. And you might find someone that you can hook up with to collaborate on a project. Hire someone. Why don't you? So that's jobs.adafruit.com. There it is. All right, let's see, what's next? How about, let's talk about our JP's product pick of the week. You may know that I've got a show on Tuesdays where I go over some of my favorite product picks, a new one each week. This week it was this 1.5-inch grayscale OLED display that's 128 by 128. And rather than me talking about it here and now in the present, let's go back in time and I'll talk about it back on last Tuesday. It is the 1.5-inch 128 by 128 grayscale OLED. It has 4-bit grayscale color, which means 16 different shades of gray. Here you can see I'm displaying some delightful grayscale images, an Ansel Adams camera. You'll see we get a really nice responsive display here, and as I click my little encoder button, I can go and change the different levels on this graph. Using these muted colors in the 16 color palette that we have works really well. That is my product pick of the week. It is the 1.5-inch 128 by 128 pixel grayscale OLED display with Stemma QT. I love it. You should go grab one. I'm going to put it on my Stemma QT wall of wonders. And I will say thank you for stopping in to watch the show and for buying them. As I suggested, hey, maybe you want to go grab one. We sold a bunch of those and we were selling them at half price. So that's one of the things that we like to do during the JP Product Pick of the Week show is offer a discount. In this case, it was 50% off. I think we sold about 40 of them, which is great. And those should be arriving in your mailboxes soon. So I'm looking forward to seeing a whole bunch of projects out there using that delightful little OLED. One thing that I didn't demo on the show, but I mentioned, is that little gizmo I built. Do I have it over here? I think I put it inside. That has MIDI output, so I'm actually using it to control different synths, including an iPad synthesizer, or a bunch of different iPad synthesizer apps. So I think that that's one really great use of that display, for me at least, will be little control surface UIs. Let's see, this is a great time to, oh hey, Mr. Certainly, I'm just peeking over at the Discord chat there. Thanks for stopping by. So let's now jump into a little thing that I think we all like to call the MakeCode Minute. All right, so this is my project of the week for the MakeCode Minute. For the MakeCode Minute this week, I wanted to show that you can use the Trellis M4 inside of maker.makecode.com, which is fantastic. This I only recently realized is as a beta extension, and I'm using the beta of maker.makecode. And what I'm using it for in this case is to set some different color strips of LEDs on the Trellis M4 and play back different musical tones when I press the buttons. So you'll hear, let me turn up some volume back here. All right, so thank you for letting me play through a little musical performance with that. So here's how this works inside of MakeCode. You'll see I just have two loops going on. One is my start loops. This is all the setup. In here, you'll see I am setting up a NeoPixels strip to have separate ranges so that I could run these very neat little gradient commands on the 4 rows that I have. And they each have 8 buttons, so there's 8 columns. And then you'll see I'm creating a little array that's going to be used to play my different musical notes. Then I have another array that I'll use to multiply those frequencies for the different rows so that I get 4 different octaves. Then in order to essentially scan through the button rows and find which button is pressed, I have this. First, I loop through an index of the different rows, and then I loop through an index of the different columns. And for all of those, we check and see, is a keypad button pressed at that current index? If it is, then I find out the current color of that button to store that as a variable for later so I can put it back. Then I set that button to white so it shows me that it's been pressed. I play a tone, and what I'm doing is grabbing from the array of notes that I already made and multiplying it by that array of octave multipliers. Then I pause for 100 milliseconds, so that sort of helps me with debouncing. And then finally we set the color back to where it was. And so that is how we can create a little button interface using the Trellis M4 inside of maker.makecode.com. And that is your MakeCode Minute. So needless to say, I was very excited to find that there's a way to use this delightful little piece of gear right inside of MakeCode now. I think I had seen one beta at one point of a different extension, and I'm not sure what the state of that is. I think there was one out there that actually had little light up color pickers, which would be really cool. So I'm excited to see continued development of code inside of MakeCode for using the lovely little Trellis M4, Neo Trellis M4. And a couple of notes on that. I'll unplug it now so I can hold it up here. There's a headphone out, so I had that out running into a guitar effects pedal, which was giving me that reverb, which is why we were hearing something a little better than just the dry tones coming out of here. And then I have it running into a little amplifier back here that I'm using, sort of a guitar amp that isn't really a guitar amp, but so that's one use of this. Another thing I was doing with this was I also have the HID keyboard extension loaded, and I was using this just as a keypad for typing in A, B, C, D through Z, and then 1, 2, 3, 4, 5, 6, because there's 32 pads on there. So you could use it for a macro keyboard if you got really fancy with that, but I figured the better demo was to do a little music with it. So if you've got one of these and you've been wanting to play around with it in a graphical interface, please go check that out. All right, let's see, what's up next? How about a MakeCode arcade game pick of the week? So what I want to show here today is called Some Space Game by Cat. And this is an entry in the forum.makecode.com inside of the arcade channel. And Cat says, hello, so this game is obviously heavily inspired by Inner Sloth's Among Us. I wanted to make a story type game rather than a multiplayer game like Among Us is. I felt there's so much you could do with this concept that Inner Sloth has provided, so I've begun to make this game. Feel free to put suggestions, improvements, and ideas down below. I will update regularly. So if you go and check it out, let's open up the full game view, and I'll restart this. So you can see it's more of a storytelling type of game, and it's just a rough early concept, but I love the visuals. I love the way this is designed here. You can say, Captain, welcome aboard. What's your name, young astronaut? And now we have a little entry here where we can say what our name is. So I'll say JP to be quick about it. Hello, Captain JP. So that's really nice. You can see that the text entries now utilize the name that you entered. And then we get these terrific animations. Look at these. You can see there's some errors and things happening because it is early beta of this, or alpha really. But really appealing looking characters, and I love that animation when they're headed in this direction. And already some discussion in the forums about how to fix some of these issues or suggestions for new features. So it's fun to look in the forum there as people participate in the creation of this. Here's L. L says, hello JP, I'm L, and this is Benny. There's Benny. He doesn't speak much, but we love him. Benny. And that's it. I don't think there's any other gameplay in here right now. I don't think the buttons are doing anything other than advancing conversation. But if we head on over to the MakeCode arcade and take a look at the code. I've collapsed the code except for this one block, which I want to look at, which is this function called Captain Speak To. And here you can see some of how the dialog parser of grabbing your name variable and inserting that works. So this is really interesting if you've ever wanted to allow user input and then incorporate that user input into the way text is constructed with this text join command. So that is just a little glimpse at something going on in this game. That is my MakeCode Arcade game pick of the week. It's called Some Space Game by Cat. Thank you so much for sharing that, and we're all looking forward to seeing your progress with that. So let's see, we'll jump back over here, and someone said that Lars is suspicious. You saw him vent. No, he's right back there. He's not doing anything. All right, let's see. What's next? I'll just pop on over to my down shooter here. Let me swap out what I've got in there. So what I'm going to show, we'll get into our main thrust of the show today. This is the Magtag. And you may have seen me on the show and tell last night showing what I've been working on with it. But I just want to show this off a little bit. I think this is still sort of beta version of the silk screen. There's some little changes and things. I'm not sure about the board. But these are in the store. We're doing batches of them. So if you want to get one, just sign up to be alerted when they're in stock. I don't think they're in stock right now, but there were some yesterday. You'll see here, you might recognize these. These are the magnet feet that we have traditionally included with LED matrix displays. They have a little M3 screw on them here on one end. And so Lady Ada included one of these M3 standoffs that are pick and placeable and soldered to the board, which are going to allow us to use kind of any M3 screw, but in this case I've got 4 of these feet on here. And I mentioned this yesterday, these things are not kidding around. Listen to this, you'll hear this, I'll stick it here, click, that is on there, that is not going anywhere. These are 4 beefy rare earth or neodymium magnets. What I've been setting it on to keep the whole thing from moving around on my desktop is a big steel plate here. You can see, clonk, it's on there. And I'll set that under the camera here so that you can see that. And let me put a little me off to the side there. There we go. And I will boost that level on the exposure a little bit so you can see it a bit better. There we go. So a few things about the board, first of all. So I showed you we've got these great little screw thread feet. There are 4 momentary switches, little buttons down here, and they're sort of labeled with arrows, left, up, down, and right, as well as their pin names, D15, 14, 12, and 11. And then up across the top we have a set of side angle NeoPixels. So the LED, the little diodes are in this little black dot you can kind of see in there. That's the direction these face, which is nice. So they're not looking straight at you. And what I've got set up on this one is on this second button here, I just have an on-off toggle for turning those on, a fairly dim sort of amber color. And you'll also notice, pluck that off of there, when I press that button or any other button, there's also a little red indicator, the famous D13 LED that'll light up. So depending on how you have this set up, you may or may not see that. If you're reflecting that off of like a white surface, you might see it. But otherwise, I found it helpful to use some of these side angle NeoPixels up here. Let's see. So other features of the board I haven't even touched yet, but we've got a couple of the JST 3-pin connectors that you can use for things like external speakers and NeoPixel strips. And then there's a Stemma QT connector there that you could use to plug in pretty much any I2C board that you need. And then what I've got going on right now, so this is this 4-color grayscale E-Ink display. And I encourage you to check out the videos that Colin has been doing about E-Ink displays. I think there's going to be one coming soon about these 4-color ones. These are 4 grayscales. The way they work is that there are black and, I guess just black, right? There's black pigment and white, right? Yeah, there's black and white pigment balls that can be raised or lowered between 2 plastic static charged surfaces, and depending on where it drops those 2, you get a couple of shades of gray as well as black and white. I think that's how that works on these, similar to the red ones, but there aren't 4 colors, which I thought originally. Instead, it's just almost like a dithering based on the white over black sort of ratio. I think that's right. Colin will probably correct me if I'm wrong. You can see here on this one we've got the white background and eyes and teeth. We have the light gray of most of the face. We have the black for the pupils, and then we have the darker gray that's used for those little antenna cups and ears, or ear cups and antennas rather. And now you'll see when I press that right arrow button, I've got it flashing on a blue set of LEDs, and that tells me that it's received my button press, so I wanted a little bit of a indication that it received the input. And then it goes and loads the next image in a alphabetical order using Slideshow. I'm going to show you that code in a little bit. So this one is just a straight black and white, so you can use straight black and white images if you want. Here is I've done a couple of variations of the logo. So here I'm using the 4 colors, and this might change a little bit, but as I've been talking with Scott Shawcroft about this, there are certain sort of ratios of the charge that are built into the specification and the drivers that these screens use. And I think Scott is tuning those right now in CircuitPython so that they'll match up with the Arduino drivers as well. And the percentage of grayscale is going to change a little from what I'm using right here as that changes. What I had determined these to be right now were 32% and 64% gray, and I think those are going to go to like 25 and 75 or something like that to make it even quarters between black, dark gray, light gray, and white. So that's no dithering. That's just the 4 straight colors. Here you can see I've got what was originally a continuous gradation, but I'm using some dithering. So dithering in this case isn't just black and white stipple patterns. And you know what? I'm going to zoom in on this a little bit more. Let me move my screen and focus it for you. 1 second, please. Let's see if we can focus that close. There we go. And kind of get that glare out of the way there. So there you can see we have black at the top of the Adafruit flower logo, and then let me see if I can find some things to point with. Here's a pencil. So this is the pure black, and then I'm starting to dither, which is use a sort of dot pattern between the dark gray and the black that is increasingly using the dark gray as it goes down, which gives us sort of a gradation effect. Then we go to pure dark gray, and then we start to dither in the light gray, and then pure light gray, and then the background is the white. So if we look at some other examples here, this is just using 2 colors of the, well, we've got black and we've got the light gray as well as the white. I'm not using the dark gray in this one, but it has kind of a nice look. There's different art styles that you'll probably want to play with as you explore these displays to find sort of the sweet spot of what the technology will allow. I think I showed this example yesterday. This is President-elect Joe Biden, and it is a what's called a head cut style illustration, which is a stippled illustrated style that the Wall Street Journal is famous for. These have been done by hand for, I don't know, 100 years or something like that. It's an interesting Wikipedia article, so go check it out if you haven't. HEDCUT. Some people think it was for headline woodcut, because it's sort of like a woodcut illustration a little bit. So here I've converted it again using both the 4 colors that we have and dithering. We get a nice effect. It looks nice up close, but you can see as you pull away, it really is striking looking. It has quite a nice, given the resolution of colors and dots that we have to work with, it's a really nice look. And of course, the E-Ink display with that sort of nice matte papery finish has a very unique and distinct look compared to other display technologies like TFT. And let's see, if we pop ahead one, you can see here is me faking that technique a little bit. This is my first try doing that using some great tutorial by Deke McClelland, who's sort of a legendary Photoshop tutorial guy. So Deke McClelland has a nice tutorial on it. I didn't quite nail it, and I may try doing the technique at the proper scale. I did it at a larger resolution and scaled it down. But so one of the key things to this look is that the stippling follows the contours of the face. If I hit my back button here, you can see I get a different color to light up, and then we go to the previous image. So you'll see that this isn't just a simple hatching, cross-hatching, or halftone type of pattern. There's something very artistic and specific about the directions of the lines, if you look at his cheek here, for example, that really follow proper contours and aren't just arbitrary dots. So that's actually something that apparently the Wall Street Journal has worked for a year training an algorithm to try to do these a little more automatically, which may or may not be a good thing, but I don't know if it'll ever catch up to the artistry of the hand-done ones. And then if I jump ahead one more time, by the way, I'll mention you shouldn't really refresh these screens super quickly. I think the manufacturers say something like a minute between refreshes for this type of technology and more like 3 minutes between refreshes if you're using the red, black, and white 3-color ones. But here you can see this is an image of an Animoji. I was inspired partly by the Ruiz brothers, who used the Animojis from the iPhone to do some puppeteering for Halloween on the Matrix portal, as well as the fact that I used this image for my thumbnail the other day, that thumbnail there. So I took that image, brought that into Photoshop, did some dithering and conversion into just the 4-color lookup table that would work on here. And so again, you see we get a nice effect of having white, black, dark gray, light gray, and the dithering. You can see here this is really nice to have this dark gray to work with for the bottom of the mushroom cloud, and the pure black in here, and then these gradations. So that, I think, is all of the images that I have on here right now. Let's see. Yeah, and back to Adabot. And so, oh, that's a good point. Todd Bott says on the Discord, now we should do the O'Reilly book animals. I'm really glad that you mentioned that. That's a terrific idea. Awesome source of, I believe those are public domain images, so anyone can use them, right? I bet we get away with that. So if you're not familiar with them, check out O'Reilly.com, and they have a distinctive style of illustrations that they use that are, I think, historic illustrations of animals, sort of photorealistic animals done with a very line and dot intensive style in sort of a black and white or a grayscale. Let's see, what else? Okay, so I said I would show the code. Let's jump into Atom here, and we'll leave up a image as we work on these. So let's go to a grayscale one. That one's black and white. Okay, so you can see here, this is the code I'm running here. This was a slideshow example that Lady Ada created and sent to me, and then I've been playing around with it to add button presses and some LEDs. So you can see here this is all in CircuitPython. There are also drivers that you can use this in Arduino. But here in CircuitPython, I'm importing a bunch of libraries, including time, which allows me to pause between updates. Board, which gives me the board definition of all the pins. Digital I/O I'm bringing in so that I can use the buttons as well as the little LED indicator on the back. Display I/O. Terminal I/O I'm actually not using because I'm not writing any fonts, any text in fonts on here. Same with label, I'm not using those right now, so those I could yank out of here or add them on if I want to try to caption these. The driver for this board is the IL0373, so we bring that in. And then we're bringing in Slideshow. And Slideshow is a really convenient library that takes care of a whole bunch of details behind the scenes for displaying images in an alphabetical, or I think there's one other order, maybe just random and alphabetical. And it just does a whole bunch of stuff that you could do if you had a reason to, but if you're just trying to display images, this gets you up and running really fast. And I'm also importing NeoPixels, so I can show those NeoPixels there. Here you can see one of the first things you got to do, and this one I've gotten caught on this before. Often you need to release the display or your display won't update. So there's a little flip that you need to do in Display I/O that allows the display to be used. And that sometimes you'll run into errors if you have this happen a little too late, like after you try setting up the display here. You need to have run this first or you'll see some errors. The display bus here is being set up as SPI. So we're using the faster SPI interface rather than I2C, which you'll also see on a lot of our displays. Often we have them both. So in this case, we're using SPI to have the fastest possible communication with the board. Then we sleep for a second after doing that setup. I'm not sure why, but I'm sure there's a good reason. Then we are setting up the display itself. So here, just a variable named display is being used for the IL0373. Which is set on this display bus, so on SPI. We give it the width and height of the display. So this display is 296 by 128 pixels. We're also telling it the orientation, so it's rotated 270 degrees off of its sort of reference origin. The black bits and color bits, these can be set during the startup as inverted. You can't do this once it's running, but if I set these to true right now, and let me unplug any other circuit playground devices so I don't save to the wrong thing. But this should, let's see, unable to save. Uh-oh, are you plugged in? No, let me plug this in over USB-C here. Yeah, who knows where that would have saved. All right, let's try that again. And I'm going to open up a serial port. There we go, it's updating. Screen dev TTY USB. Oh, it's not seeing it. Huh, all right, I will ignore that. We don't need this serial port. So now you can see everything I do is actually going to be inverted. It'll invert all 4 colors. Same stuff we saw before, but inverted. I don't know if it's possible to do that during, it's actually currently not possible, the way I tried at least, to change that after the fact, but it would be kind of nice to be able to. So we'll see if that's possible. I'll ask around. Then we have the refresh time and seconds per frame. This should normally be set, I think, at 1 minute for this display. Just in case you have it set in an auto run mode, the manufacturers say you will damage the display if you run it for days and days and days with too quick of a refresh. Then I've got all of my definitions of these buttons as digital in-outs and where they are. And you can see with this board, doing the import board, we can grab board, button D, button A, button B. So they have nice names. We don't have to call them by their digital pins. Magtag, by the way, is a ESP32S2 based board, and so it has somewhat funny names for the digital I/O compared to what you're used to, what we're all used to in CircuitPython. So I believe instead of things like D14, it would be IO14 or IOD14, something like that. Just the pin names are different for that board or for that chipset. Let's see, then we've got boards being set to pull up resistor, direction for LEDs, and pixel enable, which turns on the use of the NeoPixels. So if you use this board or any other of, I think, of our ESP32S2 based boards, and you're trying to use NeoPixels and you find they won't turn on, it's probably because pixel enable is off by default, and that is a power saving thing. Maybe it's only on this one. I actually don't know if that's turned on that way. I feel like there's one other board I've run into of ours that has that set. So I'm enabling the pixel enable value and setting it to false. So it's a little confusing, but setting it to false or setting it low, that's what allows us to use the NeoPixels. Then I've made some color definitions for use on the NeoPixels, and I'm setting it as board.neopixel. I've got 4 of them, setting their brightness really low. And then I made myself a couple of little convenience scripts here, or functions for doing things like blinking. I don't think I'm using that one, but just lighting them. Since I'm using this pixel show, I can light it to a color like black in this case, or yellow in this case. Then here's the slideshow setup. So slideshow is being set up on the display. I can't remember what this none is in reference to. The folder path, so you can set a path there if you want, whether it's auto advancing or not, and the dwell time. So this would, if you set this to true and dwell time to 180, then we can do a sort of a while true loop that's going to go and update it every minute. So I'll do a version of that, maybe have an option for that when I write up the guide for this. And then I'm also, just for debugging's sake, printing the name of the current image when it advances to it. And you can see that in the serial monitor when you have that up and running. And then this is what the buttons are doing. So actually there's one setup in here that I'm not using, but for the forward button, you can see I flick the lights on to cyan. I set the slideshow direction to forward and then advance it, and then refresh the display, and then I turn the pixels off. So that's what does that right there. So forward button getting pressed, it goes low, which is why this says if not forward button dot value, and then it goes to the next image. The one below that is the back button. You can see here I'm using this magenta color, setting the slideshow's playback direction to backward, and then it goes to the previous one. The pixel display, that's just for turning these little lights on and off. and then this is the one I'm not using. I was going to try to change folders, but I don't think I can do that way. That was I was wrong. So ignore all that right there. But the rest of that's good and it all works. So I'm going to write that up into a guide so that if you have gotten yourself a Magtag, you can start playing around with it. You'll see here also I like these. Let me hold this up to the main camera. I like these 90-degree angle USB-C adapters. So normal USB-C is going to pop it out like that. But with these, since it's USB-C, it can go in either way. So this can allow you to point it down or up. So depending on how you have things set, if you're going to mount this on a wall or something, you might not want the cable coming out at an angle. So this allows it to drop straight down or straight up. And we've got a battery charging circuit on there and a little LiPo battery, so I can unplug this and it keeps on running. And of course, this being a E-Ink display, we can also turn it off entirely. If I unplug the battery from it, it's going to stay, that one image is going to stay on there forever and ever. It never goes away because of how E-Ink works. So I think that is it for today. So thank you for stopping by. Thanks for hanging out in the chat. I'll be hanging out in the chat a little longer if you have any thoughts or questions. Did I miss anything? I think that's it. We did a lot, and I look forward to putting a guide together for this so that you can follow along, and I'll put some images up there. Again, thank you for the tip for the woodcut images to Todd. There's also a good time for questions and answers. We can hang out a couple more minutes. One question from Hugo in the Discord chat is, are the 90-degree USB-C adapters available in the shop? Yes, they are. Let me bring up my, there we go, that'll work. Bring up my browser here. If you go to Adafruit and type in, I think, right angle, that'll get you there really quick. It's item 4432. It's $5.95. Apparently I bought one last on December 6th, 2019. I just have the one, but I might get another one because these are really convenient. So that's available in the store. There you go, Hugo. Toddbot asks in the questions very sincerely, how do I play Doom on Magtag? Very slowly. About 1 frame per minute. It's an exercise in patience. No disagreement from Lars. So yes, that's your answer. I think that's it then. Thank you again so much for stopping by. I also want to thank our own C. Grover for this guitar pedal, which is the Giga delay. That's what I was using to make the Trellis M4 sound bigger and badder with a little bit of reverb on there. And that's going to do it. All right, well, thank you, everyone, and I will see you next week. Don't forget to stop by on Tuesday for my next JP's product pick of the week, and then on Thursday for another John Parks workshop. For Adafruit Industries, I'm John Park. I will see you. Bye-bye.